Here's a new way to solve systems of equations. We're going to learn to eliminate one of the variables using algebra. An important property to remember is that we often add a number to both sides when solving. And the reason we can do this is because there's something called the addition property that says if you add the same thing to both sides, the equation is still a true statement. And you can always do that. Keep that in mind looking at this first example. See how negative 2x is equal to 13. That's like saying negative 2x is 13. They're both 13. Negative 2x doesn't look like 13, but they are equal to each other, so they're interchangeable. That means that whatever you can do with 13, you could do with negative 2x instead. So now watch how I connect this property with this property. Remember, we can add the same value to both sides of the equation. So I'm going to add the 13 to this side of the equation, but I'm going to add negative 2x to this side of the equation. I can do that because they're equal. It's like adding 13 to both sides. Now, if that kind of blows your mind, you should really back up and listen to that one more time. It's a really important concept, but it's pretty abstract the first time you hear it. So don't hesitate to stop the video and go back and watch the beginning one more time. I'm going to move forward. So what does that look like? If I add that, these turn into 0, right? They're just gone. I have 3y left on this side, and I have 18 on this side. Now it's pretty easy to solve for y, so let's do it. We just divide by 3, and y is equal to 6. So I have one of my solutions. I need to plug that back in to get my x, just like we did with substitution method. So looking at my two equations, one of them doesn't even have y in it, so I'm going to plug it into this equation. 2x plus 3 times 6 is equal to 5. So 2x plus 18 equals 5, and we solve it using all of our normal properties. I'm going to subtract by 18. So 2x equals negative 13. And we can divide by 2. So x is negative 13 halves. Okay, so our solution seems to be negative 13 halves, 6. Now remember, we're supposed to always plug these things back in. But we have kind of a strange system of equations this time, because the first equation didn't have a y in it. Now, if we had been trying substitution method, we might have just solved that equation for x to begin with. And if you do, notice when you divide by negative 2, you get negative 13 halves right there. This has already been verified. Let's look at a more typical example. These are the kind of problems where we use elimination method instead of substitution method. If you look at the two equations and you notice that the coefficients of either the x's or the y's are opposites like these are, that's the perfect equation for trying elimination method. Now remember, it's based on this principle. Negative 12 is equal to negative 4x minus 2y. Those two sides are equal to each other. So this is really the same as negative 12 right there, that whole expression. And so you can add that to one side of the equation and add the negative 12 to the other side of the equation. What it looks like, it's as if we're just adding one equation to the other straight down. Make sure you line up the equal signs before you do this. So as we add like terms, negative 4x plus 4x is 0, so we eliminate the x's. Negative 2y plus 8y is 6y, and negative 12 plus negative 24 is negative 36. Now solve for that y. So I'm going to divide by 6, and y is equal to negative 6. Once we know what y is, we need to plug it back into one of those two equations. It doesn't really matter which one. I'll just plug it into this one. So 4x plus 8 times negative 6 equals negative 24. Let's simplify. That's a negative 48 right there. Let's add 48 to both sides. So 4x is equal to 24, and we can see that x equals 6. So we've got our solution, but we need to check it. Since I've already plugged it into the bottom equation, let's plug it into the top equation to check that. So that turns into negative 4 times 6 minus 2 times negative 6 is supposed to be equal to negative 12. Let's see. So negative 24 plus 12, is it equal to negative 12? Well, yes, this is equal to negative 12, isn't it? So we verified it, and this is the correct answer. All right, let's try the next one. When you look at this system, look for the part that tells you elimination method would be better than substitution method. Look at the y's. Notice their coefficients are opposites. We've got positive 1 and negative 1 right there. So I'm going to add the two equations together. I get 3x, and the y's are gone, and on this side we get 30. So x is 10. Plug that back into either equation. How about that one? So 2 times 10 plus y equals 19. Let's subtract 20. So y equals negative 1. And now we've got our answer. Looks like it's 10, negative 1, but we need to verify it, so let's plug it into the other equation. 10 minus, be careful with the negatives right there, is supposed to be 11. Remember, this is like a negative 1 out in front of y. It's a coefficient, so it gets multiplied by the value of y. Well, that's just like adding 1, so 10 plus 1 is 11? You bet it is. So this is the correct answer. All right, let's try one more example so I can show you one more trick. Okay, when you look at this problem, you don't see coefficients that are opposites here or here. So you might think we can't use elimination method, but that's not actually true. There's something we can do to transform the system into a system the elimination method works great for. You know how we can add, subtract, multiply, or divide both sides of an equation by a number, and it still is a valid equation. It'll still be a true statement. I'm going to use that property right now. I'm going to multiply this equation on both sides by the number 2. Let's see what it turns into. I get 10x plus 4y equals 202. Okay, and remember our other equation looked like this, and it still is. Now this is turned into a system where you can use the elimination method because I've made the coefficients opposites of each other. You can do this any time that you see that one coefficient is a factor of another one, or if you have one, you can multiply it by anything and turn it into an opposite. Okay, now that I've got opposites for the y's, I'm going to add everything straight down, and I get 11x is equal to 209. So divide by 11. And that's 19. So we've got our x, and we need to plug it back in somewhere to find y. I like to use the original equations. You can use the equation that you created. That will also work, but I prefer to go back to the original equations just in case I've made some small error along the way. I just feel like it's a little safer. Let's plug it into the top one. So that turns into 19 minus 4y equals 7. And we just solve. So subtract 19, and that is negative 12. Divide by negative 4. So it looks like y is 3. Our answer should be 19,3. We need to plug it into the other equation we haven't used to verify. So I'm going to plug it into that. So 5 times 19 plus 2 times 3 should be equal to 101. Well, let's see. 5 times 19 is 95, and 2 times 3 is 6, and if you add those together, it's 101. So that works, and this is the correct answer. So there's an introduction to a new method called elimination method, and you can go try it on any of the problems that you previously thought that you had to use substitution for. You can use either method and you'll come up with the same solution. So look carefully at the problems and see if they seem better suited to substitution or elimination, and go for it.